Good morning, sir. I am C. Nikila from ECA department. My assignment topic is mechanical sensors. Mechanical sensors are very important because they help us measure physical quantities like force, pressure. In this presentation, I will explain four important sensors. First, strain gauge, and second is the tactile sensor. Third, piezoresistive pressure sensor, and third, variable reluctance sensors. So first let us understand what a mechanical sensor. A mechanical sensor is a device that converts mechanical quantity into electrical signal. For example, when force or pressure is applied to a sensor, some physical changes occur inside the sensor. This change is converted into an electrical output. The basic signal chain is very simple: mechanical input, transduction element, and electrical output. Depending on the sensor, the output can be change in resistance, voltage. Mechanical sensors can be classified based on what they measure. In our presentation, we mainly have three categories. The first is force sensors, which include strain gauges and tactile sensors. The second is the pressure sensors, which include piezoresist sensors. The third is the motion and position sensors, where we use the variable reluctance sensor. Now let us understand the strain gauge. A strain gauge is used to measure strain or force when an object is stretched or compressed because of an applied force. Its dimensions change slightly. The strain gauge is attached to the surface of the object, so the gauge also deforms because of its length and cross section area change. Its electrical resistance also changes. This resistance changes is measured using a Wheatstone bridge. The bridge produces an output voltage related to the applied force. Strain gauges are commonly used in load cells, weighing scales, force and torque measurements, and structural health monitoring. Their main advantages are high accuracy, good repeatability, compact size, and low cost. Next, we have the tactile sensor. Tactile means related to touch. So, tactile sensors are used to detect physical contact and the force or pressure produced by that contact. A tactile sensor usually contains many small sensing elements arranged as an array. When an object touches the surface, different elements experience different amount of pressure. The sensor reads these individual signals and creates a two-dimensional touch map. So, tactile sensors are used in robotic grippers, prosthetic devices, touch screens, and wearable pressure mapping. Their main advantage is that they can detect force at different points over a surface, similar to the human sense of touch. However, they can have limited long term durability, complex wiring, and may require periodic calibration. Now let us discuss the piezoresistive pressure sensor. This sensor is mainly used to measure pressure. It contains a thin silicon diaphragm with piezoresistors on it. When pressure is applied, the diaphragm bends. This bending produces mechanical stress in the piezoresistors, which changes their resistance. The piezoresistors are connected in a Wheatstone bridge. Because of the resistance changes, the bridge becomes unbalanced and produces an output voltage. These sensors are used in automotive systems, medical blood pressure monitoring, and industrial process control. Their advantages include high sensitivity, fast response, and small size. Their limitations include sensitivity to temperature, possible non-linearity at high pressure, and the possibility of diaphragm damage under strong shock. Finally, let us look at the variable reluctance sensor or VRS. This sensor is used to measure speed and position. It consisting of a permanent magnet and a pickup coil placed near a rotating tooth wheel. When a tooth comes near the sensor, the magnet reluctance changes. This changes the magnetic flux through the coil. According to Faraday's law, a changing magnetic flux produces an electrical voltage. As the wheel rotates, the sensor produces electrical pulses. The pulse frequency tells us the speed, while the pulse count can be used to determine position. Variable reluctance sensors are used in crankshaft and wheel speed sensing, gear tooth position sensing, and ABS system. They are simple, rugged, and do not need external power because they can generate their own AC signals. However, their output depends on speed, so they perform poorly at very low or zero speed. They also require a ferromagnetic target wheel. So, to conclude, we have discussed four important mechanical sensors. Strain gauge measures force or strain through a resistance chain. Tactile sensor detects contact and provides information about the distribution of force. Piezoresistive pressure sensor measures pressure through resistance changes caused by diaphragm. Variable reluctance sensor measures speed and position using changes in application. Within this, I conclude my presentation. Thank you for giving me this opportunity.